Welcome, my dear learners. In this session, we shall be looking at implicit differentiation. Up until now, we've been looking at explicit differentiation, which is just the normal differentiation we have been doing so far. So, explicit differentiation is when you have a normal y function, which is in terms of x, which means that when you have a y function which is written in terms of x, like those that I've written here, they are all y functions written in terms of x. So we can say that all these functions that I've written down here, y is equal to x squared, this and that, are explicitly defined in terms of x. Now, what if these functions are not explicitly written in terms of x, but these functions are written in terms of x and then y? That's in a multivariable function where c is a constant. Then we can say that these functions are implicitly defined. Examples of such functions are, we have x squared plus y squared is equal to 4. So you can see that this function is written in terms of x and then y. So you can say that this function is an implicit function. Now when we come to the example 2, we have 2x cubed plus y power 4 is equal to 6xy. So this function is not written explicitly in terms of x only, but it is written implicitly in terms of what? X, but in the form of x and then y, because we have two variables. Now the next example, we have x cubed plus y cubed is equal to what? 12. This function is written in terms of what? X and y. So this function is an implicit function. I believe you understand. Now that we know what implicit functions are, how do we then find the derivative of these functions? How do we find the derivative of this function? So we are going to go through some steps which will guide us to find the derivative of these very functions. So these are the very steps that is going to guide us to find the derivative of implicit functions. It says, first one, differentiate both sides with respect to x. And then 2, add dy dx whenever you take the derivative of y. 3, make dy dx the subject. Somebody may ask, why do you have to add dy dx whenever we take the derivative of y? Now remember, by chain rule, whenever we are to differentiate a function, we differentiate outer, we differentiate inside of the function. So let's take it that we have the function y squared and then we have to find the derivative of y squared. So we are going to apply the chain rule. So the chain rule says we differentiate outer or the outside function. So the outside function is y squared. So we are going to get, when we differentiate y squared, we differentiate the outer functions. We are going to get 2y and then 2 minus 1. Then we differentiate what? Inside. The inside function is y. So at the end, we are going to get 2y and then dx of y. We are getting what? Dy dx. Now also, when you have y power 3, we have to find the derivative of y power 3. Now applying the chain rule, we can see that we differentiate the outside function. So the outside function is giving us what? 3y power 2, and then we differentiate the inside function, which is y. We are getting dx of what? Y. So at the end, we are getting 3y squared dy dx. So that is why we add dy dx whenever we differentiate y. Let's take examples and then see how best we can try. So we have the first example. We have to find the derivative dy dx if x squared plus y squared is equal to 4. So we are just going to follow the steps and then we are good to go. So first it says differentiate both sides of the equation. So we are just going to differentiate both sides of the equation. So we are just going to pass the d dx of y squared is equal to d dx of what? 4. Now d dx means we have to differentiate these functions with respect to x. That's the differentiation notation. So we are just going to differentiate this function with respect to x. So when we differentiate x squared with respect to x, we are getting what? 2x using power rule. So we have 2x. Now when we differentiate y squared using the chain rule, we are going to get 2y, and then I said we add dy dx, so dy dx, and when we differentiate a constant, we get 0. So we are looking for dy dx, so we can just bring 2x to the other side of the equation. So we can say that our 2y dy dx is equal to negative 2x. We are looking for dy dx, divide both sides by 2y. So we can see that 2 and then 2 will go away. Therefore, our dy dx is equal to negative x over y. We take our next example. So we can see that this function is an implicit function. So we can apply the implicit differentiation method. So we differentiate both sides of the equation. So we have d dx of s cubed plus d dx of y cubed is equal to d dx of what? 6. So when we differentiate s cubed, we are getting 3x squared by the power rule. And then when we differentiate y cubed, we are going to get 3y squared, and then I said you add dy dx. And then when we differentiate a constant, we are getting 0. So we are looking for dy dx. So we just have to bring the 3x squared to the other side of the equation. So we are going to get 3y squared dy dx is equal to negative 3x squared. We are looking for dy dx, so we divide both sides by 3y squared. So we have our dy dx is equal to negative 3x squared all over 3y squared. Now you can see that 3 and then 3 will go. Therefore, our dy dx, that is the derivative, is equal to x squared all over y squared. There's a negative here. And this is the derivative or the gradient function. We take the next example. So how are we going to find the derivative of this very implicit function? Applying the same method, we take the derivative on both sides of the equation. We make our dy dx the subject. So we are going to get d dx of s cubed. Then we differentiate y cubed. And then we take the derivative of 6y. Now we know that when we differentiate s cubed, we are getting power rule 3x squared. And then when we differentiate y cubed, chain rule, we are getting 3y squared. We add our dy dx. and this is equal to, now we can bring the 6 out, but you can see that x and y, they are multiplying, so we can apply the product rule, which says that we keep the first function, we differentiate the second function, plus we keep the second function, we differentiate the first function. So we keep the first function, which is what, x, then we differentiate the second function, which is y. When we differentiate y, we are getting what, dy dx, plus we keep the second function, so the second function is y. Now we differentiate the first function, which is what, x. When we differentiate x, we get 1. So we are going to get 3x squared plus 3y squared dy dx is equal to, now let's expand, we are going to get 6x dy dx plus 6y. Very good. Now the next thing we are going to do is we group the dy dx at one side and those without the dy dx on the other side of the equation. So let's bring this to this very part. So we can say that our 3y squared dy dx, we have this, we can bring this one here. So we have 6x dy dx is equal to, we have 6 here, 6y, then minus 3x squared. Good. Now we are looking for our dy dx. So we can say that our dy dx, we can factorize dy dx out. So we factored dy dx out. We are left with what? 3y squared. Then we have minus 6x is equal to 6y minus 3x squared. Now we are looking for dy dx, so we can divide both sides by this. So we have 3y squared minus 6x, then we have 3y squared minus 6x. So you can see that this and that to go, we are left with dy dx is equal to 6y minus 3x squared all over 3y squared minus 6x. Now from here we can factor 3 out because we have 3, which is common to all of them, and then we have 6. So we can say that when we factor 3 out here, we are getting y minus x squared all over. Now when we factor 3 out here, we are left with what? Y squared minus x. So 2 is supposed to be here, sorry. We have 2y. Good. So you can see that this and that to go, we are left with 2y minus x squared all over y. 2 is supposed to be here also. So all over y squared minus 2x. So this is the derivative, which is also known as the gradient function. So let me simplify it here. dy dx is equal to 2y minus x squared all over y squared minus 2x, and that is that. We take the next. So how are we going to find the derivative of this very function? So applying the same method, we differentiate both sides of the equation. So when we differentiate x cubed, we are getting 3x squared plus, now this we have product, so we are going to product of two variables. We have to apply the product rule. So we have our 4 out. Now with the product rule, it says that we keep the first function, so we keep x, and then we differentiate y squared. Good. Plus we keep the second function, so we are keeping it, and then we differentiate the first function, which is what? X. And then when we differentiate a constant, we are getting 0. So we have 0. When we differentiate 3y cubed, we are getting 3y squared. We add our dy dx. Very good. So we are going to get 3s squared plus we have 4, which is out. Now we have x, which is this very part. When we differentiate y squared, we are going to get what? 2y dy dx. Plus when we differentiate x, we are getting 1. So 1 times y squared, we are getting y squared, which is equal to 3y squared dy dx. So let's expand the bracket. So we have 3y squared plus 4 to 8, 8x y dy dx plus 4 times y squared. We have 4y squared is equal to 3y squared dy dx. So what we are going to do next is to bring all the dy dx to one side of the equation. Okay, so let's bring this one to this very part. So we'll be left with 3x squared plus 4y squared is equal to 3y squared dy dx. This will give us minus 8x y dy dx. Now the next thing we are going to do is to make dy dx the subject. So in making dy dx the subject, we factor it out. So we are going to get 3y squared minus 8x y. So we divide both sides by that. So we are going to get our dy dx is equal to this x squared plus 4y squared all over 3y squared minus 8x y. So this is the derivative of the implicit function above, and this brings us to the end of today's lesson. But remember, we can also use the partial derivative to find the derivative of implicit functions, and I'll be doing that in our next video, or you can search for it in the shorts. Bye bye.